right, so today we're going to start chapter 6, and we're talking about solving systems of equations. There's going to be 3 ways we're going to do this. We're going to do it by graphing, substitution, and elimination. So today we're going to talk about graphing. So before we start, read this warm-up problem and think of your answer. All right, so 2 babies, Luke and Jill, are born on the same day. Luke is 6 pounds and Jill is 9 pounds. Luke gains 1.5 pounds per month. Jill gains 1 pound per month. So how many months is it before they're the same weight? What is that weight? So I'm going to make a table here. And let's say we'll put the month here, and then Luke's weight and Jill's weight. So when they're born, Luke starts off at 6 pounds, Jill starts off at 9 pounds, and then we're going to go up from there. So let's just write some values and see what we can get. So Luke is going up 1.5 pounds per month. So we're going to go up to 7.5, 9, 10.5, 12, 13.5, 15, 16.5, etc. And then Jill's going up by 1. So we have 10, 11, 12, 13, 14, 15, 16. So we look here, they are both 15 pounds at 6 months. So at 6 months, that's when they're the same weight. So 6 months, how much do they weigh? 15 pounds. So if you don't want to type in and find a bunch of answers, you can just graph these equations. So if we write that out, Luke is going up 1.5 pounds per month, and he started at 6 pounds. Jill's going up 1 pound per month and started at 9 pounds. So we can graph these two equations. We'll do Jill in purple and Luke in blue. So if we start off here, Luke starts at 6, our y-intercept. And then every month he's going up 1.5 pounds. So we're going to go up 1.5, up 1.5, and then keep going up 1.5. Like that. So this is our graph. Now you can switch to Jill. She starts at 9, so right here, and then goes up 1. And you can see right here is their intersection. So we can come down here. That's at 6 months, or over at 15 pounds. So they're intersecting at 6:15. So 6 months, 15 pounds. Okay. So what is a system of equations? A system of equations is 2 or more equations together, and that makes a system. A solution to the system is something that makes all of the equations true. So it satisfies everything. So if we check here, we want to know if 2, 3 is a solution to this system. So start by plugging in 2. So we want 4 times 2 minus 5. And we'll end up getting 3 for that. And then plug in 2 plus 1, we'll get 3. Here, we're getting the same thing. So this is a solution. This would be yes. The next one here, we have 4, 1. So plug in our 4, and we want to check to see if we get 1. So -2 times 4 plus 7. This is going to give you -8 plus 7, which is -1. So this one works. We got -1. Then plug in 4 minus 3. That gives you +1. Well, that's not -1, so that doesn't work. So this is not a solution. Okay, so how do you solve by graphing? Kind of talked about this, but you can graph both of your equations, and where they intersect is your solution. So if we're looking here, this is at 2, 1. So the solution would be 2, 1 to this equation. You can then check by taking that 2, plugging it in here, and seeing if you get an answer of 1. So let's do some examples. So I'm going to start with this one over here. We'll do purple for this line, and let's do green for this one. So purple, we're going to start at -4, and then use the slope to go up 2 over 1, up 2 over 1. When you're doing this, make sure you're filling your whole grid so that you know where they intersect. You don't want to be sloppy and then get the wrong intersection point. So draw in your line, and then we'll switch to a green right here. We're going to start at +8 for that one, and then go down 2 over 1 from our slope. And you can draw on your line. And where they intersect, so right here, that's our solution. So the solution is going to be the 1, 2, 3, 2, so 3, 2 is the solution. Same idea for the next one. So I'm going to do blue there, and let's do purple here. So blue, start at 5. We're going to go up 1 over 2, up 1 over 2 to follow the slope. And keep doing the same. Draw your line. And do the same with the purple line. So here we're starting at 2. And then we're going to go down 1 over 4, down 1 over 1, 2, 3, 4. And then to reverse to go up and 1, 2, 3, 4, up and 1, 2, 3, 4. Draw your line. And then right here is our intersection. So that's at -4 right there, and up 1, 2, 3. So our solution is -4, +3. Okay. So pause the video and try this one on your own. All right, so we'll do purple and blue. Purple, we're going to start at -4, go down 2 over 3, down 2 over 3, reverse it to go up 2 over 3. Here's your line. Switch to blue, start at -10, so way down here. Up 1 over 3, up 1 over 3, up 1 over 3. Here's our line. Here's the intersection, so that is at 6 here and -8. So 6, -8 would be your solution. Okay, so you don't always have your equations in slope-intercept form, but before you can graph them, you need to have them in slope-intercept form. So we can rewrite these here. This one I can add the 3x to both sides, so we'll get y equals 3x minus 7. And then this other one here, you can divide everything by 2. So y is going to equal -1x plus 9. And then graph from here. So we'll start at -7 and go up 3 over 1 for the first one. And then down 3 over 1. Here's our graph. Switch to purple. We'll start at 9, and then we're going down 1 over 1. And you get this equation. And then our intersection is right here. So that's going to be, if we go over 1, 2, 3, 4, and it's up 1, 2, 3, 4, 5. So we have 4, 5 as a solution. So equations don't always intersect. So we have a different couple options here. We have what we did here, and they intersect, and this is our solution. We have one solution right here. But you could have parallel lines. So we talked about that last chapter. You could have something that's like this, and they never cross. So there's no solutions. And then the last option, you could have something like this, and then you could have another line that goes right on top of it. So those two are the exact same line. So you have an infinite number of solutions because they match up everywhere. So that's it. Go on to Math Excel and do the 6.1 assignment.